Hello everyone, welcome to SE Inc. Network. With the latest news, the state of California, Caltrans, is building a new superhighway that requires reinforced concrete column design to meet a set of listed specification and performance objectives for earthquake loading. SE Inc. has been asked to submit a bid to Caltrans, and the design team within the incorporation that produced the lowest cost design that also meet the following criteria will be chosen for the state submittal. Regarding the criteria, the design must withstand a 400 kips in axial loading, and it must also resist an earthquake loading between 64 and 96 kips. In addition, it must also withstand a 10% lateral drift without failure, and failure is defined as a 25% reduction in maximum achieved lateral force at maximum displacement. Today, we will go behind the scenes of Ingenium, also known as Team 14. Next is Arash with the proposal design.
The initial designs of the team were to design a square or a rectangle. The final design was decided upon a rectangle with a 60 by 50 cross-sectional area with 10 number 14 bars vertically and 60 number 8 bars as stirrups. The stirrups would be placed 0.25 inches apart for achieving the best plasticity for the column. To see whether or not the final design of the rectangle with the designated numbers of bars would work to the best of its ability, the PM diagram had to be found. The PM diagram tells us whether or not the column would perform within the required boundaries. There are 3 points on the PM diagram from my right to left. The first one is the lowest boundary, the left one is the higher boundary. The column was supposed to go through the middle of these 2 points. It was seen that the column does so, and the final design was decided upon the rectangle, a 60 by 50 with 10 number 14 bars and 60 number 8 bars.
Thank you, Arash. Now I will be discussing the computer graphics section for the column model. After the design phase, the column is modeled in AutoCAD and SolidWorks to establish a 2D and 3D representation. The AutoCAD illustrates the column model in the column designs and longitudinal and transverse rebar spacings. The SolidWorks illustrates the 3D representation of the column design.
Thank you, Geraldine. For my part, I will be talking about the structural analysis of our project. After analyzing from AlphaCalc, it produces an Excel sheet giving us the values of the strain, the neutral axis depth, the curvature, and the moment. From these values, we can calculate the yield moment, the yield curvature, and the nominal moment. The yield moment and yield curvature when the strain is at 0.00172. From this, we interpolate, and that produces our values. For the nominal moment, we take the average moments after the first yield. Then, using the equations given to us, we are able to calculate the idealized yield curvature, the deflections, and the force. Our predicted force was 46.3 pounds.
And thanks we had for the analysis. Our construction, we started the process by soldering and making the cage. Once the cage was built, we put it in the mold that we had made for the base from foam boards. And then when we put the cage in the base mold, after the hydrostone was cured, we put the mold around the column, and then we poured the plaster of Paris. The plaster of Paris ratio was 2 to 1. After that, we just waited for the plaster of Paris to cure.
Regarding the cost for the material, the table above shows the details of the material that were used. We spent the total of $58,328.34, and the most expensive part of the project were the concrete material with hydrostone and plaster of Paris costing $13,065 per bag.
As for our results, our column was able to displace at 1.5 inch without failing. And looking at our hysteresis plot, the forces at this displacement was 49.99 pounds and 34.5 pounds, which means our average was 42.25 pounds.
The overall performance of the column was in the expected region. As you can see from the column to my right hand side, the plastic hinge was created at the bottom of the column where it was predicted. The failure of the column actually did happen towards the end, again as it was predicted.
Regarding the errors, in the computer modeling phase, some dimensional errors were found that had not been exposed during the design phase. Other errors include limitations for precision abilities because the construction phase began before the computer representations were established.
The recommendations for efficient design and construction will be that definitely using more efficient and more accurate tools, using and doing more accurate measurements, and also decreasing the price and decreasing the cost of the whole project by reducing the cross-sectional area of the column.
Overall, our design was a success, and we ranked 4th within the team competition.
to us from
Caltrans has just say it. Just say it.
After the design phase,
Oh my god, I think.
Three, two, one. And thanks for the